Hey everyone, welcome to our bonus video here. We're going to be talking about how to find the average rate of change of a function, and this does come from your textbook, page 59, example 6. So the example that you're given is if f of x equals x cubed minus 3x, we want to find the average rate of change. Part A asks from x1 equals negative 2 to x2 equals 0. And then part B asks you for from x1 equals 0 to x2 equals 1. So I've color-coded these x values as red, and we're going to keep our x's as red throughout the work that we're going to see here. If you guys have a red and a blue pen, that's probably going to be helpful when it comes to working through this. So, first thing is that the rate of change, remember, is another calculation for a slope, and we know our slope formula between 2 points is very simply y2 minus y1, sorry, my stylus is having issues here, all over x2 minus x1. There we go. So if we think about that, y sub 1 is really the same thing as the function's value at x sub 1, and y sub 2 is the function's value at x sub 2, then we have a new formula that we can kind of use here for our rate of change, and that's the one that I have in the box for you. So our new formula looks like this. We still have subtract and subtract, okay? But our new formula is f of x2 minus f of x1 all over x2 minus x1. So now what remains for us is to just do some calculations here. So first off, if we're plugging in from x sub 1 equals negative 2 to x sub 2 equals 0, this is our part A calculations, then x sub 1 we're going to plug in and figure out what is f of negative 2. And of course that's very simple to do. We can just simply take negative 2 and cube it and subtract off 3 times negative 2, which is negative 8, because negative 2 cubed comes out as a negative number, and then plus 6, and that comes out to be an f of x1 comes out to be negative 2. F of x2 in the same way, let's leave our formula at the top there. That's going to be f of 0, because x2 is 0. So that's very simple. Should just make that 0 cubed plus 3 times 0, otherwise known as 0. Okay, so now that we have all of those moving pieces, remember, we want to go back to our formula and plug in our blue numbers, our y's at the top here in the numerator, and our x's, our red numbers, in the denominator. So this x and this x, okay? So this is what we're going to get. Average rate of change. We'll go ahead and put the subtract signs in there right now. Your blue values, remember we have f of x2 first, so that's 0. Minus f of x1 is minus a negative 2. And then my red values are my x's, and that is x sub 2, or 0 again, and then minus f of x2, which is, minus x sub 1, which is also negative 2. So we have the same numbers. This is just a coincidence here. You will not always have the same values in the numerator and the denominator for your function values and your input values. It's kind of a misleading example because they're not always going to be identical, but in this particular case, they are. So this simplifies out to positive 2 in the numerator and positive 2 in the denominator, And so our final answer for our average rate of change between these two values is 1. So now we're going to look at our graph here, and we're going to see if this makes sense. So I'm actually going to switch to a different slide here, which is a screen capture of our GeoGebra program, and we'll show you that yes, indeed does make sense. So as we start on this graph, we first need to find the value of the function at -2. And so if we put that point on there, we can see that it's also -2, the y value. Then we want to find the function's value at 0. And of course, we can see it going through the origin. But if we click on the point, there it is. Now what we want to do next is we want to connect these 2 points with a segment and figure out its slope. So first off, there is the segment, and our tools in GeoGebra allow us to find the slope of any segment between 2 points. And we're going to go up to put a triangle on the segment, and you can see that the slope comes out to be 1. This indeed does make sense.
So that's your answer to A.
Okay, as we go on to example part B here of example 6, part B, we're given just some new values for our x1 and our x2, but the process is exactly the same. So again, find f of x1, or in this case f of 0, and f of 0 is going to be, as we just got before, remember, that's going to be 0 cubed minus 3 times 0. You can tell I'm doing this during a prep period because there's our bell. Sorry about that, you guys. Which of course comes out to be 0. We actually found that value before because they used 0 as one of the values that we were going between for part A. Now we'll do f of x2. F of x2 in this case is f of 1. And so we've got a new calculation here. What is 1 cubed minus 3 times 1? Well, of course, that's 1 minus 3, or -2. So as we plug in our values, we're going to take -2 minus 0 in the numerator. And in the denominator, our x values subtracted. So that's 1 minus 0. And that math comes out to be -2 over 1, or in this case, our average rate of change, or our slope between these 2 points, is -2. Now again, we want to check this with our graph, so I'm going to put in another screen capture here as we look at the 2 points on the curve of f of x between 0 and 1 next.
Slope between 0 and 1, plugging on the point 0, 0. And when x equals 1, tracing down to the function, we have -2. So 1, -2 is the point. Then we want to find the slope between those 2 points right there, connecting that with a segment. And then just as before, turning on the slope measurement tool, we'll have a little triangle put on the segment itself, and you can see the slope is -2.
Okay, and last but not least in this video, I wanted to give you guys an example to do OYO on your own. So, and it does say check your answers at the bottom of the page. You can see it's upside down in the corner there. So we have a new definition for our function. Our new function is this time x squared minus 2x. But we're setting it up the exact same way. So see if you guys can come up with the average rates of change for these 2 parts. And that should be your preparation for going through and finding the average rate of change of a function. Make sure that you guys look for the examples in your homework for today that have a double asterisk next to them, because those are going to be some additional practice problems that you can have to get ready for the bonus on your quiz. Good job persevering this far, and good job going above and beyond, you guys. Nice work. See you next time.